As you might imagine, it's insanely difficult to figure out how big our galaxy is. After all, we live inside it, and massive clouds of gas and dust obscure our observations of it. And as everything else in space, it's much bigger than it seems. New research finds that the Milky Way stretches nearly 2 million light-years across, more than 15 times wider than its luminous spiral disk. This number could easier help us figure out how massive the universe is and how many other galaxies orbit around it. It's well known among astronomers that the brightest part of the Milky Way, the pancake-shaped disk of stars that houses the Sun, is about 120,000 light-years across. Beyond this stellar disk is a disk of gas. An immense halo of dark matter, which is full of invisible particles, covers both disks and extends far beyond them. But because dark matter is composed of particles that do not absorb, reflect, or emit light, it's very hard to figure out how big it is. For the first time, Alice Deason, an astrophysicist at Durham University in the UK, has located the Milky Way's edge. By using other nearby galaxies, they calculate that the precise diameter is a massive 1.9 million light-years, give or take 0.4 million light-years. That's more than 7 times wider than previous estimates. To find the Milky Way's edge, Deason's team conducted computer simulations of how giant galaxies like the Milky Way form. In particular, the scientists sought cases where 2 giant galaxies arose side by side, like the Milky Way and Andromeda, our nearest giant neighbor, because each galaxy's gravity tugs on the other. The simulation showed that just beyond the edge of the giant galaxy's dark halo, the velocities of small nearby galaxies drop sharply. Deason and her co-workers looked at existing telescope data and found that small galaxies near the Milky Way slowed down at the same rate of speed as the Milky Way. This happened about 950,000 light-years from the Milky Way's center, which marks the galaxy's edge, say researchers. 35 times as far away from the center as the Sun. Although dark matter makes most of the Milky Way's volume, the simulations show that stars can also be found at these faraway places. Deason says both of them have a well-defined edge. The edge of the stars is very sharp, almost as if the stars stop at a certain radius. In the future, astronomers will be able to be even more precise in calculating the Milky Way's edge by discovering additional small galaxies nearby. As Mike Boylan-Colchin, an astrophysicist at the University of Texas at Austin, says, astrophysicists could also look for individual stars at the boundary of the Milky Way. The farthest such stars will be very dim, but future observations should be able to find them. The measurement should also help astronomers tease out other galactic properties. For instance, the larger the Milky Way is, the more massive it is, and the more galaxies there should be revolving around it, says Rosemary Wise, an astronomer at Johns Hopkins. About 60 satellites of the Milky Way have been found so far, but astrophysicists think there are many more that have yet to be discovered. Thank you for watching our video. If you like this content, please hit the like button and subscribe to the #1 source of news within science and technology.